We're going to begin the course talking about things to keep in mind as we go through different problems and encounter different ideas. Things to think about when working with data. We'll call this statistical thinking. So the first thing to think about is the context of the data. So for example, if I gave you a table of some numbers, and I've got an X column and a Y column, and suppose I told you that these are jersey numbers of some soccer players, and asked you to do something meaningful, and perhaps maybe we'll take this a step further and say the X column is the jersey number of some youth soccer players one year, and then they get a new jersey the next year, and that'll be our Y column. So if I ask you to do something meaningful with this data, there's really not much you can do. We could subtract these numbers, but that doesn't tell us anything interesting about the players. We don't know. That doesn't tell us anything about how many goals they scored or any other stats, how fast they run, how much better they are than anybody. There's nothing interesting we could get by finding the difference between these numbers. Similarly, we couldn't get anything useful if we found the mean between these two numbers, that is the average, or possibly maybe dividing these two numbers or adding them up. There's nothing we could do with this data to make it to give us any interesting information. So just knowing that these are jersey numbers of some soccer players, we can't really do anything statistically interesting here. However, now let's suppose I told you that instead these are the weights in kilograms of 5 students at the beginning and at the end of freshman year. So for the first person, they had a starting weight of 56, and at the end of freshman year, they had a weight of 53, and say we're talking about kilograms here. Well, then we could get some interesting stats out of this data, because we could see with this first person, we see that they lost 3 pounds, the second person lost 1 pound, the third person gained a pound, the fourth person gained a pound, and the fifth person gained 4 pounds. So maybe we might find the average of all those differences and use that to suggest that the average difference or the average amount of freshman gains is whatever the number comes up to be. So the context of the data, what that data actually represents, can really change how we interpret that data and what we can do with it. The next thing to think about when you're working with data is the source of that data. Where did the data actually come from? So let me illustrate this idea and why it's important with this example. In 2003, a study by Enstrom and Cabot found no statistically significant relationship between secondhand smoke and lung cancer. Now this probably goes counter to basically what most people feel about secondhand smoke, or what you've heard about secondhand smoke. But nonetheless, in 2003, we had this study that showed that there was no statistically significant relationship between secondhand smoke and lung cancer. So you might be doubting it at this point. So what if I told you that this study was published in the British Medical Journal, which is a well-reputed medical journal, and suppose I told you that this was funded and managed by the Center for Indoor Air Research. So this sounds like a very legitimate study, but if we dig a little deeper into where this data actually came from, the source of this data, the next thing I tell you is that the Center for Indoor Air Research is a research organization that was created by 9 tobacco companies. So clearly, because these tobacco companies have something to gain or lose depending on the results of the study, and they're funding the study, we really cannot trust where this data came from. Or in other words, we can't trust the data that came out of this study. So the source of that data, although it's sometimes obfuscated, we have to dig as deep as we can to figure out who funded it and where that data came from to make sure it's reliable. Another thing to think about when working with data is the sampling method. That is, the method we use to collect a sample from the larger population from which we collect data. So the classic example is a 1936 Literary Digest poll which predicted that Alf Landon would defeat Franklin Delano Roosevelt by a landslide. So, of course, you may not have heard of Alf Landon because he was not actually elected president. It was indeed Roosevelt. So the question would be, why was this Literary Digest poll so far off? And there's a couple good things, but a couple bad things about this sampling method, the method they used to select their people that they polled. They sent out 10 million sample ballots, which is a good number, and asked voters to return them. 2.4 million voters responded. So there is something wrong with that, and we'll get to that one in a moment. But here's the issue with the sampling method that they used. They used lists of phone numbers, driver's registrations, and country club memberships to select people who got the ballots. But think in terms of 1936, the people who had phone numbers, or rather the people who could afford a telephone, were a little better off than some of the other people. Keep in mind, we're in the era of the Great Depression. Same thing with the driver's registrations. The only ones who could afford cars were the ones that were well off, and of course country club memberships still holds today. They're generally the folks that are a little better off than others. So they only sent these ballots to people who were fairly well off compared to the rest of the population. So that's certainly going to skew the results of their poll. It turns out that the newcomer Gallup poll, which you've probably heard of, they're much bigger than a Literary Digest poll these days. This Gallup poll used a random sample technique and polled just 50,000 people, and they actually got it right. They predicted Franklin Delano Roosevelt to win. So this random sample technique, and we'll get into this a little bit in a minute, the random sample technique is a much better technique to choose who's going to get these ballots than just going off phone numbers, driver's registrations, country club memberships, or some other specific group of people. Another thing to think about, you have to be careful about the conclusions that you reach when you're working with your data. The big statement in statistics, and this will come up over and over again throughout the semester, is that correlation does not imply causality. Meaning that just because two things are correlated does not imply that one causes the other. So, for example, a study looking at smokers finds that smokers have a higher pulse rate. Can we conclude that smoking causes someone to have a higher pulse rate? We cannot, actually. We can say that they are correlated, that as one goes up, that is, as the amount you smoke goes up, your pulse rate will go up, but we can't say that one causes the other. Possibly, although this is probably unlikely, maybe having a higher pulse rate means you're going to smoke more. One maybe a more plausible explanation for the correlation would be that possibly somebody who is more stressed out is going to have a higher pulse rate. Also, somebody who is more stressed will be more likely to smoke. So it may not be that the smoking actually causes the higher pulse rate. It may be the stress that is causing the person to smoke and is causing the higher pulse rate. We can't say just because these two things are correlated that one causes the other. There may be some other factor that is causing the higher pulse rate. So one more thing to think about when you're working with data is the practical implications of a study. So consider this study looking at the Atkins weight loss diet, which showed that 40 subjects had a mean weight loss of 2.1 pounds after 1 year. So the question is this statistically significant? So for example, if I were on an Atkins weight loss diet for a year, I certainly would hope to lose more weight than 2.1 pounds. So even though this study seems legitimate, assuming this wasn't funded by Atkins, but if this study is legitimate and there is actually a mean weight loss of 2.1 pounds, that wouldn't suggest to anybody that you should go run and jump on the Atkins bandwagon. because you'd only expect to lose about 2.1 pounds after a full year of being on the diet. So you have to consider the practical implications of these studies.